Neobay Robotics Forum is an academic platform launched by Science Robotics in collaboration with the Institute of Medical Robotics, Shanghai Jiaotong University, aiming to promote the latest advances in robotics and allied technologies, as well as ongoing basic science research and engineering challenges. The online forum is open to the general public and held monthly with speakers from leading research organizations and industries around the world.
Why I would focus my talk on healthcare robotics, especially rehabilitation and assistive robotics. Recent publications show that there is a huge interest in this area, and also the health expenditure is much increased in the last 2 decades. You can hear from the robot report showing a huge interest in healthcare robotics in general, but especially for exoskeletons and wearable technologies. And the key for this inclusion in this closed loop is for sure the picture that we can construct about the patients by monitoring the patients in its global state, his global state, for example, including information about the biomechanics, so motion information about the user, as well as physiological information about the user, for example, vital parameters or muscular activities, or also cortical activities. All this information can enable the machine to adapt its behavior to the patient and perform a behavior that is tailored on the user. So this is the meaning of biocooperative systems used in rehabilitation for closing the patient in the control loop of the machine. This type of approach is basically multi-parametric, but also modular, so we can change the type of sensory systems included in our multimodal interfaces for application on patients with muscular dystrophy, as here in the top on the left, or also in rehabilitation treatment with post-stroke patients. Here, for example, on the right, we have changed the robotic machines. We're using an upper limb exoskeleton, but also the interface is completely different because we are using an EEG cap in this case. For prosthetics and bionics, we need to understand what the user is thinking. So we need to decode the motion intention and provide this information to the artificial hand for moving in the external world and grasp and manipulate object. But we also need to give back this information to the user by means of a sensory feedback. And we need to do that of interfaces with the nervous system in order to enable this bidirectional communication. When moving on more distal amputation, for example, transradial amputation, we can find in literature several examples on neural interfaces implanted in the nerves, especially in ulnar and median nerves. And also in our experience, we closed the control loop by means of neural interfaces. So combine two different types of neural electrodes, intraneural and cuff electrodes. And we were able to show that using some specific encoding algorithm, we were able to recover sensation about force, its touch, and also slippage. Slippage is a very important information for providing the amputee subjects with the ability to manipulate objects.
At the time, when we looked at our hand, we started asking a question. Do we really need a frame? Because humans already has bones. So we said, I mean, the reason that people cannot move their hand is not because they don't have frames. It's just the muscles and the signals. So we said, okay, let's remove the frames and start building a robot without these kind of rigid materials. So this is when my research on soft wearable robot began. So that's why we changed the material to polymer. So this is Dr. Brian Kang. Now he's a professor at Sejong University in Korea. So he developed a exoglove poly, which is based on the polymer. The reason we changed the base material to polymer was for hygiene issues. And we had several improvements. And now it became easier to wear. So to wear the glove, you have to put the glove into your hand, but this one had this kind of openness, which could be easily put onto the patient. And the key technical features were pretty similar with the exoglove. We had the under-actuation. So as you can see, with the under-actuated mechanism, we can actually drive 2 fingers with one motor, but you can adaptively grab different objects. A new paradigm where you can use a video. So instead of using a biosignal, we actually use a glass with a camera, and the person can actually just look at his hand, and by looking at his hand, he can actually know his intention when to grasp. This was possible because our glove has under-actuation mechanism, so it doesn't need a complicated control. You just need to know when to start grabbing. So because our method predicts the user intentions from the on behavior and the hand-object interaction, the planar construction, and this is the overall wall motion. We built this customized assembly we designed the stiffness to be to match the belly stiffness for higher efficiency of the robot. And as you can see, I'm not sure if you can hear the sound, but if you can hear the sound, so we built a device which can be controlled with a joystick, and he could pressure his belly to actually sing by himself. Was that instead of using muscles as a motor, you can actually use muscles as strutting tendons or brakes or springs. So instead of focusing on the muscle as a motor function, we used tendons. We used passive tendons, which can change the force field around your body. And we designed a suit that when you wear this, it will reshape your movement. So if the suit makes a stooping motion, a high impedance, if you wear this suit, you will automatically do a squatting. So that was the intention of this suit.